Well, guys, so today I'm going to explain all the questions that we had in the assessment academic in the first simulation. Let's start, okay? Okay, so first question, calculate 6 divided by 2 plus 4 times -3 being squared. Now, just use the bitmass concept, right, to do this question. Pretty easy. Now we see that we have index here, right? So let's do that first. So this, if it's being squared, there'll be 9. Okay, remember that this is -3 all being squared, meaning that it's -3 times -3, which is just equals to 9. Now we can actually do this at the same time, which is equals to 3, and then like this, right? And then we have a multiplication, right? So we have the index, we have the multiplication here, which is 36. So it's 3 plus 36, which is equals to 39. So that is the first question. Okay, question number 2. In the test, when students answer a question correctly, they will get 5 points. If the answer is incorrect, their point will be reduced by 2. Okay, be careful with this word over here, which is being reduced. So, which means that it's being deducted. So you subtract them, right? When there's no answer, they will not get any point. From 100 question, Akira managed to answer 80 questions, and he got 62 correct answer. What is Akira's score for this test? Okay, so we only need to find the score, meaning we only focus on the one that he answered because there's no point to calculating the unanswered question because there's no score for them. Yeah, so it's just the number of correct answer multiplied by 5, right? And then the number of incorrect answer multiplied by -2. So it's just like we know that 62 got correct, so there'll be 62 times 5, right? Because they're the correct answer, the point of correct answer is 5, and then add them with we know that there are 80 question that he answered, meaning that the incorrect answer should be 80 minus 62, which is equals to 18. So and then 18 multiplied by, again, because it's negative reduced by 2, so it's multiplied by -2. And then if you answer this one will be 310, right? 62 times 5, and this will equals to -36. And then if you subtract them, they'll be equals to 274. So this is the answer for question number 2. Let's go to question number 4. Number 3, sorry. Let me just take the question here. Okay, so wait a minute. Okay, after 40% discount, a jacket is priced at $70. What is the original price of this jacket before the discount? Okay, now a couple of ways on how to do this. The one that I really like to use in simple logic is that this price over here is a price after discount, meaning that the original price will be higher than this one. Now, if we know that the original price is always 100%, let's say I'm going to write that here, original price is just 100%, right? Right? Oh, which means that this one is 100% minus with the discount. Now we know that there are 40% discount, meaning that this guy over here is just 100% minus 40%, which is equals to 60%. So this is just 60% of the original price. So if we write that down in terms of equation, you can say that, oh, let's say the original price, for example, is P, denoted by P. So if I multiply 60% with the original price, they'll be equals to $72. Right? Right, so this is the logic behind that. So remember, when we want to solve any algebra equation, we only need to like move everything. Like we see that in here, P must be itself in one side of the equal sign, so we need to get rid of this guy over here, right? So what do? We only need to divide both sides by that number, which is 60%. Divide by 60%, and you get this being cancelled and divided by 60%. So if you're having trouble in doing this one over here, so you can write it down actually like this. So 72% divided by 60%. We know that 60% can be also written as 60 over 100, or you can cancel this too. That'll be 6 over 10, or you can simplify it again, becomes 3 over 5. So this number here can be actually written as 3 over 5. Right? And remember, when we have a fraction like this, like a number being divided by another a fraction, you can actually do this. Okay, so what I like to do first, I'm not multiplying the 72 and 5 first, I'm going to divide the 72 by 3 first instead. So if I divide 72 by 3, they'll be equals to 24. So I'm going to cross that, and it will be 24. So 24 now is just being multiplied by 5, which is equals to $120. Okay, so this is the first method. Actually, we can have a different method, which is ratio, but pretty similar actually. Now, let's do the logic again. So let's say P is the original price. Okay, P is the original price. And it represents again 100% of the price, right? And then let's say the discount price is D, right? The discount price is that, and then we need to know what is the discount price in the percentage of the certain price in terms of the original price. Then again, when we do this one over here, right, so we know that it's 40% discount, meaning that the what do you call this price here is just like 100% minus 40%, which is equals to 60%. So I can say, oh, between that, the discount price is just 60%, right? 60%. So you can write down like this. Oh, so the price, the original price, the ratio of the original price with the discount is equals to 100% over 60%. And you can see that you can cancel the percentage here, right? And you can also cancel the 0. Okay, let's just stop here. So 10 over 6. And then the number, the original price, we don't know the original price, right? So let's just be P. But we know that the discount price is 72, right? It's from the question over here. It's 72. Now, by comparing these two numbers, you can see that you can do like a cross multiplication, right? So I'm going to rewrite that again. So with 10 over 6 equals to P over 72. So you can like just multiply both sides by 72 if you want, right? So just multiply by 72 over here, multiply this by 72 over here, so that you can cancel the 72 over here. And then you can see that this one here is the same thing like we did over previously. It's like 5 over 3, and this is just 120, and you get the value of. Okay, let's move on to number 4. Okay, take the question here. Okay, solve for the value of y from the equation 2y minus 5 over 3 equals to 17. Now, again, the very basic concept of solving an algebraic equation with one variable is just like make the variable alone in one side of the equal sign. So by this, if you have a fraction, it's the best way for me, I think, the best way on how to do this is to get rid of the denominator first. So you have 2y minus 5 over 3 equals to 17. So I'm gonna get rid of this 3 first. So by multiplying both sides by 3. Yeah, so if I do that, the one on the left side is canceling this 2, which is just 2y minus 5, and on the right side it'll be 50. Now again, the same thing like we always did, right? So just remove this 5, adding 5 on both sides, so it's just plus 5, and that'll be just 2y. On the right side we have 56, and then divide both sides by 2 because we have 2 over here, right, being multiplied by the y. That's why we divide. So divide this by 2, divide it by 2, you can cancel the 2, and this is just 1y or just y, and this is equals to 28. So that is the question, the answer over here. Yeah, I forgot to, yeah, this one is this one. Yeah, I forgot. Okay, so let's go to number 5. Number 5 is about angles. I'm going to copy and paste the image here. Okay. From the image below, what is the value of x? So we see that this sign over here. So that sign represents a right angle. Right angle is 90 degrees. So which means that if we add all of these 3 angles, this guy, this guy, this guy, they'll be equal to 90 degrees, right? So you don't have to worry about the unit because all of them has been given here. So I can just write down an equation as the first one over here, which is x plus 3. And then if I add that with the second one, which is x minus 1, and then add again with x plus 1, I will get equals to 90, right? So you see you have x plus x plus x is 3x, and then this one being cancelled, and just plus 3 equals to 90. Then again, pretty easy. Just subtract both sides by 3, you will get 3x on the left side, and that'll be equals to 87, and then divide both sides by 3 to get it over 3. Divided by 3, that'll be just x on the left side. And on the right side, there'll be 29. And there we go. We have the value of x. Okay, let's go to question number 6. It's still about angles. Okay, we'll go. Okay. Okay, from the image below, calculate the value of y. Again, we have 2 lines that are parallel. So, did I mention that is? Yeah, they are parallel. So you can see that if we have this sign over here, right? So this is actually how do you call it? If we see like something like this, right? So which means that these two lines A, B, and C, D are parallel. So let's assume that they are parallel. So we can use a couple of theory. So for example, like this one, if this is y, if let's say this is a straight line, right? So we can say that this angle here is just 180 minus 127 because this is a straight line, right? Now, if we have that, you can write down as, okay, let's name that with, for example, A. So angle A will be equals to 1 out of 80 minus 127. That will be just equals to 53. So 53 is over here, right? Now, to find the y value, also you need to find the x value first, because in here we have a triangle, right? So remember that the concept of angles in a triangle will always be, if you sum that up, you'll always get 180 degree. Now, in here, the x value is actually this guy over here, right? Remember what we call the alternate interior angle, right? So that is going to be the same. So this guy over here will be equals to this guy. Now you can see that if we expand the line, for example, from here, right? So if we expand the line over here and then like that, right? So you can see that this two are the same, yeah? They are the same because this also same with this one, but we don't really need that. Now, for now, we can see that if this is the same, so the x will be equals to 50. Then again, if we add this, and this, because they are inside a triangle, so if you add all of everything, you'll get a 180 degree. Right, so there's another way on how to do this actually, but yeah, I'm gonna show you later. But for this one, is the x value is just okay, so the y value, so is the, if I add x plus y plus a, you will get equals to 180 degree. So we know that the x is 50, right, from here. And then we know that the a is 53, so it's plus 53, so it's a plus y first, because I wrote a y first before the a. And then plus 53 equals to 180. So if we add these two, there'll be 103. So plus 103 equals to 180, and which means that the y will be equals to 180 minus 103, which is equals to 77 degree. Okay, that's one way how to do it if you want to use the triangle. But actually, there is another way. Now, if we know that this angle here is actually also alternate with this one over here, right? So that is also interior, they call it in alternate interior angle. Yes, okay. So meaning that if I add the 50 with the 50 with the y, you will get 127, right? That is also another way on how to find it. Now, if you do that, if we use that concept, you will get let me write it down here. So I get y plus 50, so these two, right? And then equals to this guy over here, 127. And you can see that y equals to 127 minus 50, and you will get the same exact value. Okay, so there's a couple of ways on how to do it. It's up to you in what way, on what point of view that you see this problem can be solved. Just do based on what you most comfortable with. Okay, let's go to number 7. Number 7 is about ratio. Okay, yep. The ratio of boys to girls in the class is 5 to 7 respectively. So in here, the boys is represented by the 5 and the girls is represented by 7. If there are 30 boys, how many girls are there? Okay, so it's pretty easy. You can write down, okay, boys over here and then girls over here. Sorry, girls, L and S, L and S, girls. And then if you compare them, the ratio will be just 5 to 7. Now, because this guy represents the number of boys, so you can write down 30 over here. And since this is what we call the direct proportion, so if you multiply here, you go multiply also over here. So remember that basically ratio, if like we have only 2 of this, you only like doing a fraction. Like for example, if I have 2 over 4, you can write it down as 1 over 2, right? So how can you do that? Because you can just divide both of these two numbers by the same number, right? You're not changing the value of this fraction, but you just like, okay, just simplifying it. So the same thing with this one, right? So if we see that 5 to 30, we know that this is multiplied by 6, or you can say that 30 divided by 5 is equals to 6. So meaning that this guy over here should also be multiplied by 6, right? So 7 times 6, which is equals to 42. So that is the final answer. Pretty easy, right? Okay, let's go to number 8. Okay, this is a two-dimensional shape. A rectangle has a length of x plus 3 centimeter with a width of 4 centimeter. If the perimeter of this rectangle is 30 centimeter, what is the value of x? Now, if you cannot like imagine what really happened, I suggest that you draw the figure first. Okay, I'm going to draw a rectangle because it talked about rectangle. So if this is the rectangle, now it's said that the length of the length is x plus 3 centimeters. So this is x plus 3, and the width is 4. And then set also that the perimeter is 30 centimeters. Now we all remember that perimeter is just adding all of the side in the shape, right? Like if this is 4, this is also 4. If this is x plus 3, this is also x plus 3. Then again, because this is a rectangle. Now, when we talk about perimeter, you're just adding all of these numbers. X plus 3 plus 4 plus x plus 3 plus 4. That's it. And you will get 30. Right? So in terms of the equation, you can write down x plus 3 and then plus 4 and then plus x plus 3 and then plus 4. They'll be equals to 30. Or you can just add these two numbers and then multiply by 2. It's the same thing. Yeah. Okay, so if we add them together here, we have 2x, right? Because x plus x equals to 2x. And then we have 3 plus 4, 3 plus 4. That will be just 7 plus 7, which is equals to 14. So 2x, let me write that again. 2x plus 14 equals to 30. You only need to solve this equation, right? So 2x equals to subtract both sides by 14. You will get 30 minus 14, which is equals to 16, right? So 2x equals to 16. And I divide both sides by 2, and you'll get x equals to 6. There we go. Wait a minute, it's 8. My bad. It's 8. 6 divided by 2 is 8. Yeah, 0. Okay, so pretty simple concept. Okay, let's go to number 9. Number 9 is the same thing, same concept. Remember that, guys, that I will be giving you the formulas. So if you don't know or you forgot the formula, you can just go back to that page and then see what the formula is for the question that you want to answer. Okay, number 9, the area of a kite is 24 meters. If the diagonals of the kite are this and this, what is the possible value of x? Then again, just draw a kite. Okay, I don't have any shape here like a kite, so we just like draw it like this. Okay, like that. Sorry, my drawing is not that good. So if we have the diagonals are like this one over here, and then we have another one which is over. I'm gonna use different color. This one over here, right? So those two are the diagonals, and they are, the first one is x plus 1 and the other one is x plus 3. So let's say the red one is x plus 1 and this one here is the other one, the vertical one is x plus 3. Now the question in here we also have an information that the area is 24. Now the area of a kite is diagonal 1 times diagonal 2 divided by 2. You can again see the formula in the formula booklet. So it's just basically multiplying these two and divide by 2. So if you do that, you will get x plus 1 multiplied by x plus 3 over 2 will be equals to 24. Right? So this is the equation. Now, what can we do here? We can get rid of the 2 first. I mean, like by multiplying both sides by 2, you'll get x plus 1 times x plus 3 equals to 48, right? Because 24 times 2, which is equals to 48. Now, since we know that in this equation, there is a bracket, you can actually open the bracket, right? If we open the bracket, there will be x squared plus 3x plus x plus 3 equals to 48. And there'll be x squared because we can combine these two. They are like terms. There'll be plus 4x plus 3 equals to 0. Now, in here, we have a quadratic, right? If you see a quadratic equation, then you have to solve it using quadratic. Sorry, this is not equals to 0. This is equals to 48. Now, I'm going to do that. I'm going to like subtract both sides by 48 so that this is gone. So it'll be equals to 0. Remember that you need to solve it using the form of ax squared plus bx plus c equals 0. You can actually use a different method, but for now, just use this one. So if I do that, you'll get x squared plus 4x plus 3 minus 48 equals to 0. Now, I can write it down again. That'll be this one here will be negative 45. Now, just factorize this. Okay, you know how to factorize, right? So you can see that 45 is just 9 times 5 because this is negative. So one of them will be negative. So that'll be something like this. Okay, so if you forgot how to do this, I suggest you can see the tutorial again about how to factorize. right? So this is so x1 here will becomes -9 because we know that if this is 0, so the two the two thing inside the bracket should also be 0. So if x plus 9 equals 0, so the x equals to -9. So this one is x minus 5 equals again minus I'm actually gonna rewrite everything, okay, so that you can follow what really happened. So x plus 9 equals 0, right? So if x plus 9 equals 0, so x equals to -9, right? Because we subtract both sides by 9. This is the same thing, x minus 5 equals 0, so x will be equals to 5. So we have two values of x. Now, in terms of the context, it said that what is the possible value of x? So you might have to answer over here, but in terms of the context, you might not you might cannot use both of them. You only take one of them. And you see that if you plug in -9, for example, into this equation here, and you will get -9 plus 1, you get -8. So length cannot be negative. So that's why we cannot use this value over here. Now, if you use this value over here, x equals to 5, right? So if you plug in over here, you will get 5 plus 1, which is equals to 6. This is 5 plus 3, which is equals to 8, right? So you will get a positive number, and that is what do you call it? This making sense in terms of the context, right? So in here, we'll write down the possible value of x is just equals to 5. Let's just write down here, which is over here. Okay. Next, number 10. Number 10 is about sets. Pretty easy actually. Be very careful with union and intersection, okay, guys. So let me write down here. Given a set A equals to that, and then B is equals to that, what are the elements in A union B? So this represent this symbol here. It represent it's read union. Union means you combine, okay, union, okay. If you have something like this is what we call the intersection, okay. So union B just will combine everything, so A and B being combined. But remember that in set, that if you have the same element, just write it once. You don't need to write it down more than once. Just write it one time. Yeah, so if we write down A union B, it's just basically just writing down 1, 2, 3, 4, 5, 6. Because we know that if I write everything 1, 2, 3, 4, 3, 4, 5, 6, right, let me just write it now. 3, 4 for A, and then for B is 3, 4, 5, 6. But again, like I said before, if you have the same exact what do you call it, elements, you don't need to write them twice. Like this one here, just write them once, and then this one also have 1 over here, so you don't have to write them twice. So I'm going to erase them, and then I'm just going to combine them like this, and the answer should be option C. Okay, let's move on to number 11. Solve for the value of x from that equation. Now, if you see an like an exponential equation like this one here, and when you want to solve it, for your level, it's the thing that you need to see here is that if you have different base, so make them the same. So we have this one here, this term have a base of 3, this term have a base of 9, and this term has a base of 27. So if you, for example, you want to combine these two numbers, like these two terms, you need to make the base the same, okay? So let's rewrite that again. So this guy is just 3, this guy is 3 to the power of 2, this guy is 3 to the power of 3, right? So if we again rewrite that again, they will get 3 to the power of -3x plus 1. And then this guy here, I'm going to write that as 3 to the power of 2, that replacing the 9. And then the one under the power stays the same, so it's 2 plus 5x, right? And then the one on the right side here, 27, can also be written as 3 to the power of 3. So that will be 3 to the power of 3, and then to the power of 2x plus. Okay, now remember in index law that if you have a power being power again, meaning that you just multiply the power. But be careful when you multiply this, so it's not just multiplied by 2, but also multiplied by 5x. Okay, so if you do that, you will get 3 to the power of -3x plus 1. And then this guy becomes 3 to the power of 4 plus 10x, right? And on the right side, the same thing applies. So that'll be 3 to the power of 6x plus 9. Now, we're not done yet because this should be combined because we need so that the the form on the left and the right side has like a single term, and they have the same base. Now, again, remember that in index law, if you are multiplying with the same base, you only need to add the power. So just add these two numbers here, these two expression. So negative 3x plus 10x will become 7x, right? Let me write down 7x here. And then 3 to the power of 7x. And then 1 plus 4 is equals to 5. Okay, so that'll be equals to 3 to the power of 6x plus 9. And so you can see that both in both sides of the equation, you will have the same form in the both in index form, and both of them have the same exact what do you call it, base, right? So which is 3. So which means that we only need to take the power. So this guy equals to this guy. So if we do that, you'll get 7x plus 5 equals to 6x plus 9. And then subtract both sides by 6x, and then also subtract both sides by 5. You will get like this, right? Okay, and then this will be just x, and minus 5 is just equals to 4, and that is the answer for question number 11. Okay, let's go to number 12. Okay, number 12, we're talking about function. Okay, pretty easy. Okay, given f of x equals to 7 minus 3x, what is the value of f of 3? So remember that in function, guys, if this is x, right? So if this is 3, so you only need to replace dx by 3. That's it. Pretty easy, right? So if I have f of x equals to 7 minus 3x, so if I have f of 3, right? So this guy, again, just change it into 3. You can see that what happened is just this is x, so I'm replacing that with this. That's it, right? Pretty easy. So it's just 7 minus 9, right? Because 3 times 3 is 9, so that'll be just negative 2, and this is the answer. Okay, number 13. Okay, number 13, here we go. Find the equation of a line, sorry, I mistyped that, it's of a line, which passes through point this and this. So there's a lot of ways on how to do this, guys. You can actually go to the formula of like the long formula, but I don't really like that formula. But you can also do substituting, or you can find the gradient first, and then you can put it into the function. Okay, so in here, all of the answer is in the form of y equals to mx plus c. So remember that this one here is the gradient, and this is actually the y-intercept. Now I'm gonna go with the first method, in which we have 2 points. This is like a random point. Let's say we don't know that we don't have any gradient, and we don't know. Let's say we don't know that, but actually there is a y-intercept here, but let's say we don't know. So if you don't know that, we can find the gradient first. Okay, remember that the gradient is just rise over run. Or again, if you want to see the formula, they'll be on the formula booklet, the formula list. You'll get y2 minus y1 over x2 minus x1. So we'll name these 2 points as x1 y1 and x2 y2. Let's name this as x1 y1. This is x2 y2. So just plug everything here into this formula. You'll get equals to negative 9 minus 0. Minus 1. Negative 9 minus 1, right? And then minus 1, and then the x2 is 2, and then the x1 is just 0. Okay, negative 9, negative 1 is negative 8, and then 2 minus 0 is 2, and then you will get negative 4. Now you can see that the gradient is negative 4. Now we only need to use this formula here, right? This form of equation, and then plug in one of these two points. It's up to you. Which one do you think is easier? And then find the value of c. Now you can see that if I do that, if I plug in, let's say I'm going to use this one over here. That's 0, negative 1. If I'm using that, so which means that we have a point, and we have coordinates, and we have a gradient which is equals to negative 4. Just plug that into y equals to mx plus c, and we know that in terms of coordinates, this is the x, this is the y. So just change everything, substitute everything. Now you get the y, which is negative 1, so this guy becomes negative 1. And then the m, which is this one, negative 4, just put that negative 4 over there. And then the x, now this guy over here, which is this 0, right? Times 0, and then plus c. Okay. Now you can see that negative 4 times 0 is just 0, right? So that leaves us with negative 1 equals to c, right? So the final answer for this question, because again it is in the form of y equals to mx plus c, right? And since we know that the gradient is negative 4, so that will be y equals negative 4x, and then we know that the c is negative 1, so that will be negative 4x minus 1. Yeah. Okay, so that is this going to be just b. Okay, let's go to number 14. Okay, that is statistic. Okay, now number 14 is statistic. Wait a minute, where is the... Yep. What is the mean and the median respectively from the following data set? Okay, now when you are encountering a set of data like this, if the data has not been ordered yet, you should do that if you want to find the median or the quartiles later on. But actually, if you want to find the mean, you don't have to do that. Okay, so it depends on the question. Again, if you just finding the mean, just add everything and then divide it by the number of data. Okay, the total number of data. But if you are if you also finding out what the median is, you need to like make it in order, like from the smallest to the largest, like the ascending order. Okay, let's just do that. Okay, there's 3 over here. Okay, and then we have 4, and then we have 5, and then we have 6, and we have 7, and we have 8, and we have last one, isn't it? Okay, now 1 2 3 4 5 6 7 8 9, so we have 9 data. Okay, 9 data. Now, to find the mean, just add everything and then divide it by 9 because we have 9 data. Okay, so just add them together. You get 3 plus 3 plus 4 is 7, 7 plus 4 is 11, plus 6 is 16, that'll be 22, that'll be 29, that'll be 37, that'll be 45, and this will be 54. Okay, so that'll be 54. So the mean is just equals to the total, which is 54, and which we just did, and I divided by the total data, which is equals to 9. So the 54 divided by 9 is equals to 6. Okay, so that's the mean. Now the median is just like the middle data. So the middle data from this set of data, you can see that if we have 9 data, so the location of the median is just like this number here, which is the total number of data, plus 1 divided by 2. 9 plus 1 is equals to 10. 10 divided by 2 equals to 5. So which means that the location of the median is on the 5th data. So we have 1 2 3 4 5. It's over here, right? So again, the 5 that I'm talking about is not the median, it's the location of the median. Okay, so making sure that this is the median, you can see that if I take this number here, you see that on the left side we have 4 data, on the right side we have 4 data, and then you can see that both of them have the same amount of data on the left and on the right side of this number here. So which means that the median is also equals to 6. So this is the answer. Okay, number 15. Okay, this one is a little bit tricky. Okay, here we go. Okay, the mean score of 40 students is 80. Okay, mean score of 40 students is 80. 5 new students with a total score of X is now being added to the data set, and the mean now is 81. What is the average score of these 5 new students? Okay, now let's think of separately. So let's say we are talking about this 40 student with a data of 80. So remember that when we're talking about mean, so which means that we might want to know the total value of the data. So like the total score of this 40 student. Okay, so let's name that with sigma fx. Okay, so that is the total score of the 40 students. Okay, sigma fx1. Yeah, so let's name it 1 because we have like 2 things here. Now that will be just equals to 40 times 80, right? Because we have 40 students and the average is 80. So just remember that the sigma fx1 is actually, if we use the mean, right? So the mean is actually this divided by the total number of data, which is equals to 40 students, right? So this is actually the mean, right, guys? So if you divide the total value of data divided by 40, which is the number of data, and then you look at this number here, so which means that if we can simplify this, though, which means that the sigma f1, sigma fx1, sorry, is equals to just multiply both sides by 40, right? 8 times 4 is 32, so it's just 32, 0, 0. So this is the total score, again, the total score of the 40 students. Now let's see what happened in the second case. The second case is said that 5 new students. So another 5. I'm going to use different color here. 5 students now. 5 students. Now with a total score of x. So let's name the second one with x2. Let's just name this with x2. Sigma fx2. I'm going to say sigma fx2. Okay, that is the total score of this 5 students, right? The same thing like we did over here, right? And then it said that it's now being added to the data set, and now the mean is 81. So the mean value of the combined data is just like the sigma fx1, right? The total value, the total score of this 40 data, 40 student, and then added with the total score of these 5 students, right? And then divided by 40 plus 5, because we know that now the total students is not 40 anymore because we're adding 5 students, right? That'll be equals to 81, right? So this is the new score. So if we see that, we know that sigma fx1 is 320, and we know that this x is equals, this guy here is equals to x, okay? So if we substitute the value, guys, I'm gonna move it here a little bit. And again, we know that the sigma fx1 is 3200, so you can put that there, right? That'll be 3200, 3200. And then let's name this with x, because it said that in the question it said it's x, right? The total score, average score is x. So let's name that with x. And then the one on the bottom here, we have 40 plus 5, which is 45, and it equals to 81. So again, this is a pretty simple algebra, right? So we can multiply both sides by 45. That'll be 3200 plus x equals to 81 times 45. Okay, 81 times 45 is equals to 3645. So 3200 plus x equals to 3645. So which means that the x is equals to, just subtracting both sides by 3200. So x equals to 3645 minus 3200, and that'll be equals to 445. Okay, so this is not the one that's being asked. The one that's being asked is the average score of these new 5 students. So which means that if the total score of these 5 students is this, so the mean value of the score of the 5 students is just dividing this value divided by 5, because we're talking about this 5 student, right? So divide this by 5, you'll get the mean value now, which is just equals to 445 divided by 5, that'll be equals to 89. Yeah, there you go. 89. Number 16, there are 12 red marbles and 13 blue marbles in a jar. 2 marbles are taken from the jar one by one without replacement. So be very careful for this kind of question. It said that 2 marbles, okay, 2 marbles. So you have 2 events, okay, taken from a jar one by one without replacing. So after you take the marbles, the first marble, you don't put it back. So the marble is now being reduced by 1. Okay, so please keep in mind. Okay, what is the problem that both marble are blue? So you can actually use a tree diagram, but if you don't want to use that, it's fine. So if you draw the tree diagram, we'll be like, okay, this is like the first marble, which is just red and blue, right? And then the probability that you'll get a red marbles is just 12 over 25. The 25 comes from 12 plus 13. And remember that we just like comparing the number of red marbles and to the whole thing. Yeah, the whole marbles inside this jar. Now, which means that in here, this will be 13 over 25. So this is like the first marble. Now the second marble is also red and blue, but now the probability might be different, because we know that after you take the first marble, you don't put it back. Now the marble is not 25 anymore, which is equals to 24. So every single of the branches for the second marble here is not going to be 25 anymore. All of them will be just 24. So this is, I'm going to write down the denominator first, over 24, over 24, over 24, and over 24. Now we only need to write down the numerator. Okay, let's say for the first one over here, this guy over here, so you get a red. Now, you must see that there are 12 red marbles inside the jar, but in this branch here, right, this one, you assume that the first event that happened is getting a red. So if the red marble is not being put back into the jar, so now the red is not 12 anymore, but now it becomes 11 because you already take 1. Okay. Now the same thing with the blue one. So we know that in this branch, the red one is now being taken by 1. So the red one being reduced by 1, but the blue one stays there. So all the blue stays inside the jar. So there will be just 13. So this is 13 over 24. Now the same thing over here. So we have blue, red, right? So blue, now is being taken in here, so which means that the red marbles is all of the red marbles are still in the jar, so there'll be just 12. So this one is 12, and but this one here is blue, meaning that because we know that in this branch the first marble that is taking is a blue, so it's not 13 anymore, it's now 12. So this is the complete tree diagram if you want to draw it, but if you don't want to, you can just like use the one that being asked. The one that being asked is both marbles are blue. So we only need to take with this 4 branches, like 1, 2, 3, 4, right? Well, which of them, like maybe one or maybe more than that, is included into the category of the one that being asked, which is blue. Both of them are blue, right? So both of them are blue is actually this branch over here, blue, and then another blue. So you can see that you only need to multiply these two numbers, right? So it's just 13 over 25 and then multiply by 12 over 24. We can actually simplify this, becomes 1 over 2, right? So that'll be just 13 over 50, and that is the answer. Option E. Okay. Next, let's go to number 17. Okay, number 17 is we're talking about a circle. Okay, given the approximation of pi is 22 over 7, so if it does tells you what the value of pi is in the question, use that number, okay? So what is the area of a circle with the diameter of 28? Now, the one that's being asked is area. So remember that, again, if you don't understand, if you forget the formula, just see it in the list, okay? So the area of a circle is equals to pi r squared. Now we have the pi value, which is 22 over 7, but we don't know the radius yet, okay? It's the radius. So, but we need to connect it with this guy over here, which is the diameter. We know that diameter is twice of the radius, so meaning that the radius is the diameter divided by 2, which is equals to 28 divided by 2 equals to 14, right? So which means that you can use this formula and just substitute the pi value with 22 over 7 and the r with 14. So that'll be equals to 22 over 7 and then plus times it with r squared, which is 14 times 14. 14 squared, I can write it down as 14 times 14. Now the reason why I do that, because I want to cancel these two numbers, right? So 7 and 14 divided by 7 is just 2. And if you multiply everything here, we get 616. And that'll be the final answer, okay? Number 18. Rationalize the denominator from the surd of this. Now you can see that if you have a question in terms of surds, and which if they have a denominator in which it is a surd, so you need to get rid of that surd. Okay, so remember that the concept is pretty simple. So you can multiply with any fraction, but remember that there should always be equals to 1. Let me show you what I mean. If I write down 2 over 4, I can write this down actually as 4 over 8. This doesn't change the value of the fraction because I know that I'm just multiplying this by 2 and multiplying this by 2. So if I do that, actually, if I rewrite that, right? So this guy here, the one that I'm doing here, is just basically multiplying by 1 because I know that 2 divided by 2 is equals to 1. Any number multiplied by 1 goes back to itself, right? So which means that I'm not changing the value of this fraction. So the same concept applies if we have a surd. Now you have 24 over square root of 6. Now to get rid, 24 over square root of 6. To get rid of this, you can multiply it by square root of 6 over square root of 6. So this is, again, basically is just 1, right? Because square root of 6 divided by square root of 6 is equals to 1. So remember also that in fraction, if you want to multiply a fraction, just multiply the numerator with numerator, denominator with denominator. So this is just 24 square root of 6. The one here, square root of 6 times square root of 6 is just 6, right? Here we go. But this is not the simplest form of the surd because we can simplify 24 and 6. 24 divided by 6 is 4. So you leave that with 4 squared root of 6. Okay. Okay, this, number 19 is still, the question is still about rationalizing the denominator from a surd. Okay, put it here. Okay, rationalize a form of denominator from the surd of this. Now, this time's a little bit different because the denominator is not just a surd form, but also maybe it's like a surd, but it's like an addition or subtraction of two surds, like two terms, right? In which you cannot combine. Now, this guy and this guy cannot be combined, right? Because they're not like term. Okay, so what can we do here? So remember the concept of a plus b times a minus b equals to a squared minus b squared. This is a very powerful concept. If you see that, if you want, for example, if you do this, the one that we with the method that we just did for number 18, you'll get 2 plus square root of 5 over square root of 5 minus 2. Let's say we want to just multiply this by square root of 5 over square root of 5. Now let's focus on here first. If you multiply that with square root of 5, you're not just multiplying this guy with this guy, but you also need to multiply this with this guy. If you do that, square root of 5 times square root of 5, yes, it is 5, right? But if you multiply this to negative 2 with square root of 5, you will get another surd. See? Another surd, right? So the point is, how do we remove that surd, right? So it's not just it's multiplying not just with square root of 5, but you also need to multiply this with what we call the conjugate of this. The conjugate is the same thing like we have over here. So if I have a plus b, then the conjugate is a minus b. If I have a minus b, then the conjugate is a plus b. Because if I multiply those two, right, you'll get all of these two numbers being squared. If I square this, I will get an integer. I will not get any surd anymore. This is the same thing, right? 2 squared is just 4. Okay. So again, let's use this concept to solve this question. Now, you're multiplying with 5 plus 2, and this is equal to 5 plus 2. You can see that this is a plus b, a minus b. This is a plus b. Okay. Now, what you do here, remember that this is like a use FOIL method, like multiply this with this, and then this one and this one. Okay, so be careful with that. And then if we do that, and then the one on the denominator is pretty easy because we know this properties here is just like this square and then minus this square, right? That's it. We can use this formula here. So that'll be square root of 5 all being squared, and then minus 2 also being squared. The one on the top, we have 2 times square root of 5, which is 2 square root of 5, and then 2 times 2, which is 4, and then square root of 5 times square root of 5, which is just 5, and then square root of 5 times 2 is just plus 2 square root of 5. Okay, now what happened here is that we have like terms. Now we have this guy and this guy, right? Which is just 4 square root of 5, and then this 2, this equals to 9. And then you can see that on the denominator, square root of 5 being squared is just 5, right? And this is just 4. And you see that 5 minus 4 is equals to 1. And then if you divide anything by 1, you go to the same exact number. So this is just 4 square root of 5 and then plus 9. And that is this guy. Okay, let's go to number 20. Number 20 is about sequence. Let me just copy the question first. Here we go. Okay, given an arithmetic sequence where the third term is 11 and the seventh term is 27, what is the 10th term of the sequence? Okay, most of the time, if we see sequence, the first thing you do is to determine whether it's arithmetic or geometric. If the question doesn't say anything about it. Now, in the question, it is stated that this is an arithmetic sequence. Now, and then what we have here is the third term and the seventh term. So again, the next thing that you need to do is after determining the whether this is arithmetic or geometric, you need to find, most of the time you will need to find the first term and the common difference if it's arithmetic. If it's geometric, this is the first term and the common ratio. Okay, because this is arithmetic, so we're going to find these two. Okay, so it doesn't say anything about, because we don't know what is u1 and d, because when we answer the question here, it said that the 10th term of the sequence, remember in the concept, in the formula, there'll be un, the 10th term is equals to the first term plus n minus 1 times d. Now we need those two elements, right? So we need the two elements to find u10, right? Because this is u10, yeah, 10th term. Now what we know here is this guy and this guy, 7th term and the 3rd term. So how do we connect those two to find the first term and the common difference? Now, remember another concept that we can use, that if with this formula, actually, we can write it down like this. It's like u1 plus 0d. This is, if I have the second term, it's just u1 plus 1d. And you have a third term, there'll be u1 plus 2d, and so on, right? You can see the pattern that in here, if you have, for example, let's say we have u100, there'll be just u1 plus 99d. So you can see that you just subtracting this by 1 to get 99, because in here we have n minus 1. So with using this concept, I know that if I split the third term in terms of u1 and d, so the third term, right, from here, will be just equals to u1 plus 2d, right? This first term plus 2d. If I have the seventh term, okay, when do I get the 2? It's from minusing 3 by 1, again, because this is n minus 1. Again, same thing with u7. This is just u1 plus 6d, because we know 7 minus 1 is equals to 6. And since we know that the third term is 11, so right down here, and then since we know that the seventh term is 27, and then you get over here. And you see that we have two equations here. We can use the elimination method to find the value of u1 and d. Now, if we do that, you can actually just subtract these two equations so that we can eliminate the first term, right? u1 minus u1 is just 0. So it's just being eliminated. And then we have 2d minus 60, which is minus 4d. And then 11 minus 27, that'll be minus 16. And then divide both sides by -4. Right, divided by -4, and d will be equals to, sorry, it's not 8, it's 4. Yeah, so that is the common difference. Now, if you want to know the first term, just plug in this d into one of these equations. Yeah, just plug into one of them. I'm going to use this one over here. So if the d is equals to 4, then, which means that u1, got the first term, and then plus 2d, and since we know the d is 4, so it's 2 times 4 equals to 11. Yeah, 11. So we have 2 plus 8 equals to 11. So u1 is just subtracting both sides by 8, and then that'll be equals to 3. There you go, right? So now we have the materials, right, to be used to find the 10th term, right? The 10th term is this one here, the 10th term, which is u10. So again, without using the formula, you can actually see that u10, the 10th term, will be equals to u1 plus 9d, right? Because this is 10, this is 9. Just subtract that by 1. And then because we already know that the first term, which is equals to 3, so this is equals to 3. And we know that the common difference is 4, so this is times 4. And you will get 3 plus 36, which is equals to 39. Okay. 21, given a geometric sequence where the second term is 0.25 and the fifth term is 2. What is the seventh term of the sequence? Again, you can actually again use the concept. Again, if we have arithmetic, you will get like u1 equals to u1, u2 equals to u1 plus 1d, and then u3 equals to u1 plus 2d, and so on. But if it's geometric, you are going to multiply instead of adding, right, with the common ratio. And then the number here is not going to be like multiplying, but you are going to use it as a power. So in terms of geometric, again, let's say the first term is just first term, because we know that we have a formula of un equals to u1 times r to the power of n minus 1. So notice that this and this one is very connected. For example, this is 100 and this will be 99, right? Now, if you understand the concept again, we can actually write down a like a pattern. If I say u1 is just u1, actually it's times r to the power of 0, u2 equals to u1 times r to the power of 1. And then third term will be equals to the first term multiplied by r squared, and so on and so on, right? You can see that the one now that's being changing is the power over here, right? Okay, now again, using this concept, we know that say that second term is 0.25, so that will be u2, right? Second term equals to 125, and this is equals to the first term multiplied by r to the power of 1, right? Because I know that this one over here, right? So if this is 2, and the power is going to be 1. Okay, same thing with this one here, the fifth term, which is u5, right? So I'm gonna write down u5. This time I'm gonna write down u5 up above this u2. Okay, u5, the fifth term, and that'll be equals to 2 here, 2. And then that is actually the first term multiplied by r to the power of 4. Again, 5 and 4, right? So how do we solve for the value of u1 and r to the power 4? So previously here we are using an elimination method, right? Elimination method like this, because we have addition and subtraction. But if you have a multiplication like this, we call it ratio. Again, if ratio meaning that you're dividing, right? So we are going to compare that using a fraction. So if I write down u5 over u2, the first term divided by the second term, you will get u1 r to the power of 4 over u1 times r to the power of 1, right? So from here. Now that is equals to 2 over 0.25. Okay, you can see that if you have a fraction like this, you can cancel, right? So we can cancel this guy over here. And then in the index form, if I have the same base being divided, you only need to subtract the power. So that'll be just r to the power of 3. Again, 3 comes from 4 minus 1 because they're being divide it, right? And then just divide this. Okay, so if you don't know how to divide with the decimal, you can see that you can actually convert that to 0.25 becomes 1 over 4, right? 0.25 is actually 25% or 1 over 4. Right, so I can write this down as 2 divided 1 over 4. And you can see that I can actually also write this down as 2 divided by 1 over 4. And then that'll be 2 times 4 over 1, right? So remember what I told you about how to divide fraction like this. And then if you get that, it will be r to the power of 3 is equals to just 8 because 2 times 4 is 8. Now r, meantime, will be 8 to the power of 1 over 3. Now let me tell you how do we move this guy up here. Now it's actually not moving, so like do something on both sides of the equal sign. So if I want to get rid of this and I want to get that equals to 1, that would be r to the power of 1. So I can like do this, right? Right? Okay, what happened on the left side is just 1. It's just r to the power of 1. And 8 now being powered by 1 over 3. And then you know that 8 can be written also as 2 to the power of 3, right? So this is 2 to the power of 3 as the value of x, and the value of 8, and then to the power of 1 over 3. And you can see that now we can also multiply the 3 and 1 over 3, which is just 1. So which means that the r value or the common ratio is equals to 2. Now we're not done yet because if you want to find the seventh term, we also need the first term, right? So finding the first term, you can just like use one of these two, right? One of them to find it. So I'm gonna use the second one because that is an integer. This one here. Okay, since we know that r is equals to 2, so if I write down u7, u5, yeah, okay. u5, yeah, u5, the fifth term, that'll be equals to the first term multiplied by r to the power of 4, right? And then we know that this is equals to 2 from the question here, right? And then we can also, now we can substitute the value of r because we already know that the value of r equals to 2. So we can make this into equals to 2. So if we do that, it'll be u1 first term multiplied by 2 to the power of 4 equals to 2. So the first term, this is just 16. So they'll be multiplied by 16 and then equals to 2, which means that if we divide both sides by 16, you'll get the first term is equals to 2 over 16, or you can simplify, it becomes 1 over 8. So this is the first term. Now the one that being asked is the seventh term. Seventh term meaning that u7 is equals to the first term times r to the power of 6, right? So since we know that the first term is 1 over 8, to write down 1 over 8, this guy, right? And then r, we know that this is 2, right? Right, so just 2 to the power of 6. So actually I can write this down as 2 to the power of negative 3, guys, if I want. So if I know that 8 is 2 to the power of 3, so 1 over 8 is 2 to the power of negative 3. So I can change this if I want to. If you want to do it manually, it's fine. But I'm gonna do that because with that I have the same base now. Now you only need to add the power this time, right? So the negative 3 plus 6, which is equals to 3. So you only have 2 to the power of 3, which is equals to 8. And that is the final answer for question number 21. Number 22, for the following figure, establish that a pair of triangles is similar. Find the value of x. Now you see that if we talk about similarities, the best idea to, I think for me, is when I want to find like a certain value of this side length, for example, just draw the two figures separately and then try to like make them so that they facing the same way, right? Okay, so in here we have this two triangles, right? We see that we have two triangles here actually. The first one is over here, so okay, let me use my tool here to make it even neater. So we have 1, 2, 3 over here. There we go. So let's say that is the first triangle, and the second triangle is actually is inside the one that is being smaller. So it's this guy over. Okay, let me just write down here. We have 70 over here, so 70 degree over here, right? And then this one is 4 plus 7. Here, this one over here, which is just 11. And right down there is 11 centimeter. And then one over here, right? This guy over here is just x plus 8. Okay, x plus 8. Now, the thing that the next triangle that we can see here is that the smaller one, which is the one I'm just gonna copy this. And you can see that they are actually similar. So, but this time I'm gonna flip it. I'm gonna flip order, flip, wait a minute, let's not rotate this, flip vertically like that. But this time I'm gonna also rotate that like this, and not just that, I'm also going to make it smaller. You can see that, wait a minute, there's something like this. If you can see that if I plug that in here, it's actually fits. Yeah, maybe it's not that fit, but yeah, you see the point I'm doing this, right? So that's the second triangle. So actually that, I'm just like, if I move that there, like here, you know the 70 degrees over here. Now, in terms of the image here, the angle, if this one is on the top, this one is over there. So the best way to do this is like flip this triangle. I'm gonna flip this, rotate, flip vertically, and then we get like that. Okay, before I do that, I'm just gonna write down what we have. Over here, we have this guy here, right? So this is 7 centimeter, and this is 8 centimeter. Now, I'm gonna flip this right now because I know that the angle now is not like, okay, this is on the top, this one is on the left side, bottom, but I want that so that both of the image or the figure facing the same way. Okay, so I'm gonna do that. So I'm gonna rotate this, not rotate, actually flip it, and then vertically it's like that. Okay. Okay. I know it's being upside down. I'm gonna rewrite that. This is 7. Okay, write down 7 over here. And this is 8 centimeter over here, right? 8 centimeter over here. So actually, again, I can just rotate this a little bit to the left like this. Okay, here we go. Right. So now you can see that it's like, oh, the 70 now is in the same position. Now, the 70, this 70, I can also rewrite that again. Sorry, it's like being upside down, 70 degree. And you can see that this guy and this guy is going to correspond to each other, and this one over here will correspond to this guy over here. So you can find the x value for this, yeah? So a lot of ways how to write this down. You can write down as x plus 8 over 11 equals to 7 over 8, or you can write down x plus 8 over 7 equals to 11 over 8. It's the same thing, yeah? As long as you're not switching, yeah? So if I write down x over 8 over 11, so there'll be like the green one over the blue one, right? So you can see that I'm using color this time, and then which means that the one on the other side of the fraction is also like the yellow first, and then we go to the blue first, the second one, right? So the yellow one is this guy over here. So I'm just using color so that you can see what really happened. So this is 7, and the one is 8 over here. So again, you can do a cross multiplication, or you just like multiply both sides by 11. So you can have x plus 8. If I multiply both by 11, that'll be 11 times 7 over 8, right? That'll be just 77 over 8, right? So x equals to, this is 77 over 8, and then subtract both sides by 8. So let me write that down. 77 over 8, this one over here, it's like just 11 times 7, right? Because you can cancel the 11 and 8. So it's just 77 minus 8, and then you subtract it by 8, right? So 8 is, now you see that this is like a fraction, this is integer. So how do we do that? You can actually see that this is actually 8 over 1. You can see that. You can do like a butterfly method to do that if you want. So I'm going to do that. So 77 times 1 is just 77. And then 8 times 8 is 64, because this is an subtraction. So minus 64 divided by 8 times 1, which is just equals to 8. Now you only need to subtract, right? 77 minus 64 is equals to 13 over 8. So that is the final answer, because you don't have to change it into decimal, because in the option the options are in a fraction. Okay, let's go to number 23. 23 is geometric transformation. Okay, so again, guys, I don't really like giving you formulas, something like this. You can just like see what really happened in terms of the graph, yeah? Point A, which is it have a coordinates of 8, negative 9, is rotated 90 degrees counterclockwise with anchor point at the origin. Origin is point 0, 0 in the Cartesian plane, 0, 0. What is the coordinate of the rotation? Now, again, I'm going to draw a Cartesian plane here. Now, what happened is that this is the point of origin, this is the anchor. Now, if you rotate by the anchor, this is going to be very easy, because when you rotate it 90 degree, you're basically just switching these two numbers, the x and the y value. But in terms of the positive and negative, you can actually just see it, the position, in which quadrant is it. Like for example, this is the first quadrant, second quadrant, third quadrant, and the fourth quadrant. And here, both x and y is positive, right? Because this is positive, this is positive. In the second quadrant, now the x is becomes negative, right? Because it's on the left side, but the y is still on the top, which is going to be positive. On the third, the both of them will be negative, right? On the left side, to the left side, which is negative in terms of x, on to down, meaning y is also negative. And here, the fourth quadrant is the x value is positive, but the y value is negative. Okay, so keep in mind that you just need to see the position of the point now. Now, let's see what we have. The point A is, where is it? It's 8 comma negative 9. So it's in here. So it's in this area over here. 8, for example, 8 over here, negative 9 over here. So it's here somewhere, right? But that's point A. Now, the one that's being asked is of rotated 90-degree counterclockwise. So this point is going to go that way, okay? Rotated from here, okay? 90 degrees. So you have like if you have a line like this, they'll be like perpendicular to that because it's 90 degree, right? Okay, so what really happens is the easiest way in how to solve this kind of question is if it's 90 degree, you only need to see, okay, this is in this quadrant. If I go there, I will be here, and then both of the x value and y value now becomes positive, right? Because it's in the first quadrant, right? In this position, all of the value of x and y are positive. Okay, so which means that in here, the easiest way again, when you rotate it 90 degree, it means that you're just switching the x and y. It's just like 9, 8 being switched, and then decide whether like maybe one of the three is negative, or maybe both of them, or maybe none of them. And because again, after you switch the number here, you only need to see in the position, and the position in here is that both of them on the x and y is positive, so you will get just only 9,8. That's it. Okay, pretty easy. Okay, let's go to number 24. 24 is about inequality. Okay, be careful when solving inequality. It's a little bit different when you solve an algebraic equation with one variable. The difference is that when you multiply or divide with a negative number, the sign also changes direction. That is very, very crucial. Okay, now let's solve this one here. We have 5a minus 11 equal less than, okay, less than 10 plus 8a. Now it's up to you what do you want the variables is for the final answer. But since we have a multiple choice here in which all the options have the variables on the left side of the inequality side, so you must move like put every single of that variable to the left side of the inequality sign. Now the one that we have is the 5a and 8a, so this guy must be like on the left side. So let's just subtract both sides by 8a, right? So 5a minus 8a, and then also add both sides by 11, right? Something like this, okay? And then we know that 5a minus 3a is negative 3a, and then this is 21. And then again, when I said before, if you want to remove this, right, the negative 3, you need to divide by negative 3, right? And also negative 3. Well, but be careful that if you encounter with inequality, this also changes. This is also being divided by a negative number. Remember that negative means that you go the other way, the opposite direction, right? So for example, if I have like 5 plus 3 equals to 2, so if I say 5 plus 3 equals to 7. It's 8, sorry, my bad. Equals to 8. So how do I go back here? So I'm going to subtract them again because subtraction is basically like going backward. Now it means that going to the other way around. So which means that if I'm dividing or multiplying all of these by negative number, so this guy also changes direction. Okay, so that means if I divide this by negative 3, this is just a, but this time this guy goes to the other way around, and 21 divided by negative 3 is negative 7. So that is the final answer. Okay, number 25, it is about a three-dimensional shape. It's about volume. Okay, the volume of a cuboid A, B, C, D, E, F, G, H, as shown below, is 300. So we know the volume. And in terms of formulas, let's name this with length. This is width and height. Is the volume is just length times width times height, right? Remember, it's just like base area times height. The base area is length times width, and then the height is just height. So we're basically just multiplying all of this side. Okay, so length times width times height. That's it. Equals to 300. So what do we have here? We have AB. Let's name AB this one here, which is the width. change that with 2 square root of 5, this guy, 2 square root of 5. And then we also know the AD is 10. AD is this guy over here, which is the L. It doesn't really matter about the variable, guys, the name of the variable, as long as you understand the concept. Again, the L is 10, and then we don't know the H, right? So BG here is the one that's being asked. That is the H. I'm gonna name that with H, and it equals to 300. You can see that if you multiply this, you get 20 square root of 5. H equals to 300. Divide both sides by 20 square root of 5, right? So that you get the value of H. Okay, when you cancel that, you will get this guy here. But in the question here, you need to simplify this, and same thing like we did before. When we have a third in the denominator, we can multiply that by that. Okay, so I can cancel this first. If I can cancel the 0 here, divide both sides by what they call it, 10, and then also divide 30 by 2, you get 15, right? So you can actually write this down as 15 over square root of 5. But again, in the option, you don't have this number. You need to rationalize this, so you just multiply by square root of 5. Now square root of 5, it'll be 15 square root of 5 over 5, right? So they'll be just cancel these two. We'll get 3 square root of 5, and that is the final answer. Okay, let's go to number 26. Okay, so the full factorization from coordinate equation 12x minus x minus 35 is what? Okay, so the option here is that, so you can see that if you don't have any options, you can say that this is the number, this number here, the last one, the constant, is actually the multiplication of the two factors, and then this one is the addition of that. But in here, the coefficient of x squared is not 1, so we need to figure out something. Now we have an option, we have a lot of options here, so from all of these options you can actually try it if you're not sure, right? For example, okay, we know that 35 is 5 times 7, so every single of the option has 5 times 7, right? But you don't know which one. Now and then this is also the same thing. Well, 12x squared is actually multiplying by 12 times 1, or 2 times 6, or maybe 3 times 4. Now you can actually use a quadratic formula, but if you're finding the 0, but for this one, I think it's best way, if you have an option like this, you can just like try it one by one. Now let's try the question C, for example. Option C, for example, we have 3x plus 5, and then 4x minus 7. So if we expand the bracket, it will be 12x squared, and then this one becomes negative 21x, and it becomes plus 20x, and then this becomes negative 35. And if you combine these two, right, this is negative 21 plus 20x, there will be minus x, and then minus 35. And there we go. That is the that's the answer. Okay, so let's go move on to question number 27. Okay. Number 27. At present, Budi is 5 years younger than Ali, and if at present twice the sum of their age is at least 75 years, and it is assumed that Budi and Ali's age now are integer, meaning that, like, for example, like 2 years old, none less, none more, for example. Yeah, so let's just use an integer number. Now find the minimum possible age of Ali 5 years ago. So let's write down the equation. Now in here, you don't know Ali's age and you don't know Budi's age right now. So you have two variables there. Now most of the time, if you have two variables, you will use system of equation. Okay. Now let's write down the first equation from the first sentence here. Right. So let's name Budi's age now as B, and then Ali's age now is A. So I can write this down as B is equals to A minus A. Sorry. A minus 5, right? Because Budi is 5 years younger than Ali, so it's Ali's age and then minus with 5. Okay, if at present twice the sum of this, twice means twice, 2 times, okay, 2 times. And the sum of the age, so it's bracket, sum of the age means you add them, the A plus B, right, is at least 75. At least means that it's greater than equals to 75. Now again, so we have like an equation and we have an inequality. So the way you know how to do this, it depends on what is being asked. The one that's being asked is Ali's, right? Ali 5 years ago. So let's find Ali's age now and then subtract it by 5. Now when you do that, we have like two of this. It's best for you to substitute to use the substitution method in here, because we're looking for Ali, so we need to change the B. The B becomes this guy, right? So just substitute that. B becomes A plus 5. So we get 2 multiplied by A plus A minus 5, which is the B, right? This one comes from here. And then greater than equals to 75. Okay. Okay, here you go. 2, and this is 2a minus 5 greater than 75. You can open a bracket if you want. There'll be 4a minus 10 plus the greater than equals to 75. So if you can continue that, there'll be 4a is greater than equals to 85 because you're adding both sides by 10, right? And then a will be greater than equals to 85 over 4. So if you write this down as a decimal, you'll get 21.25, right? So a is greater than equals to 21.25. So if it said that it is integer, so the one that says in the question is an integer number of years, okay, integer years, for example. Now, if it says like greater than equals to 21.25, so the least number that is going to fulfill the a is 22, right? So the least number, because it said that the least number said the minimum possible Ali of 5 years ago. So this is the age, Ali's age right now. So if it's asking for 5 years later, 5 years ago, so means that it's just a minus 5, which is 22 minus 5, which is equals to 17 years over here. Okay. So question number 28. Okay, right angle triangle. So sorry guys. Okay, given a right angle triangle ABC where angle B is at 90 degree. Oh god. Right. If line segment AB is 12 and sorry, this is not AB, this should be AC guys. So equals to 24. What is the length of line segment BC? So let's again, if you see a question that involves drawing, for example, like shapes, now you might want to draw the shape first. Okay, this is said that we have a right angle triangle, so let's draw a right angle triangle. Okay, my bad. So again, so right angle triangle, this, and this. Okay, there you go. So right angle triangle, say we have the triangle over here, and it said that the B is the 90 degrees, so be careful with that. So the A and C doesn't really matter. The B is the one that's really mattering in this question. Now we know that AB is 12, it says here 12 centimeter, and AC is 24 centimeter. Now, what is the length of line segment BC? So let's name this with X. Okay, so because this is a right angle triangle, so which means that we can use the Pythagoras formula to find this side over here, right? So let's write the equation, let's write the formula here. C equals to a squared plus b squared. So remember that, be careful with the determining the c here. So the a and b doesn't really matter. You can switch it, but the c is very important because we know that the c is the longest side. The longest side is here is the hypotenuse, which is always in front of the 90 degree, which is this 24. So you can write this down as 24 all being squared, and then the a, let's name the a, this is b. That'll be just 12 squared, and then b squared. Okay, now 24 squared, if I'm not mistaken, is, wait a minute. Okay, that is 576. So 576 equals to, this is 144 plus b squared, and move that to the left side. That'll be 576 minus 144, and it'll be equals to 432. So this is 576 minus 144 equals to b squared. That'll be 432 equals to b squared. Now, which means that the b is the square root of 432. Now you don't have that here, but you see that in the option that every single of the option has a surd of 3, meaning that we need to split this into the multiplication of 3. So now try to divide 432 by 3 and you'll get 144. So actually 144 times 3. Now the 144 can be like pull out, right? Because we know that the square root of 144 is just 12. So this is just 12 square root of. There you go. Okay, question number 29. Okay, number 29, this is pretty tricky, guys. But again, guys, if you have a multiple choice question, if you don't know the answer, you can just like try it and just plug in the numbers into the equation. Okay. Yeah, number 29, this is pretty tricky, I think. I'm gonna write down for you guys step by step. So we have this one here. This is different with the one that we did before, because the one that we did before I forgot what number that it was. It's the when the base is 3. I forgot. Let me just scroll up a little bit. It is, where is it? It's this guy, right? So and here this is being multiplied, so it's going to be very easy because you only need to add like the power after you have the same base, right? But in this question here, you have an addition. not multiplication. If this is multiplication, then it's easy, right? But if this is not, then we need to do something with that. So in here, we can write this 16 as 2 to the power 4, right? 2 times 2 times 2 times 2 is equals to 16. So I can write this equation again as 2 to the power 4 plus 2 to the power of x equals to 2 to the power of x plus 1. Now, what can we do here? We can actually, what do you call it? We can split this 2, right? So we can split that becomes 2 to the power of x and then times 2. We know that if I have 2 to the power of x times 2 to the power of 1, there'll be 2 to the power of x plus 1. We can just add them together. I can actually go the other way around, right? So I can rewrite that. Write that this. There'll be 2 to the power of x times 2 to the power of 1. That's just 2. Now, assuming that, let's say this guy here, let's change that into a like a different variables, yeah? So let's use a little bit of manipulation here. So let's say we have let that guy 2 to the power of x. Let's name that with p, for example. So you can actually write this out as 2 to the power of 4 plus p, right? So okay, rewrite that again. Everything here, right? Rewrite it again. Change this 2 into p. They'll get 2 to the power of 4 plus p equals to p times 2, right? P times 2. P times 2 is just 2p, right? So I can write down 2 to the power of 4. Actually, I don't really need to change this if I don't want to, but maybe it's a good idea to do that. But for this time, yeah, you can see it. So we have p equals to 2p. You see, this is a very, very simple what do you call it? A very, very simple equation, right? So if I write that down, that'll be equals to 2p. Subtract both sides by p, right? You only have p, right? And then what is p? P is this guy, right? 2 to the power of x. So I can change that again. The p becomes 2 to the power of x. And you see that both sides of the equal sign have the same form with the same base, meaning that the x is just 4. That's it. Okay, that is just this guy. Okay, last question. Okay, for the okay, let me just take the question here. Okay. 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 The histogram below shows the weight of 40 honeydew melons, each measured correct to the nearest kilogram. What is the lower quartile, the median, and the upper quartile? So you're basically dividing the data into 4 equal parts. Now, there's a lot of way in how to do this. So for you guys, I think you need to create a frequency table first. Okay, so let's just make that. I'm gonna make like a box here, and then write down the x and the f. Actually, we have one more, which is fx. CF. Let me just add that one here. Okay, so what we have is from the table, from the graph. We have the x value, which is the weight of the melon. Let's name that with x. This is the x value. And then this is the frequency. Let's name it f. We also need one more, which is the cumulative frequency. So this is going to be very helpful for you to find the quartiles and also the median. Okay. Okay, let's pick another one over here. Oops, sorry. Why is it error on it? Need it. Here we go. Have this guy. Okay. Now let's start with the x values, right? The x value is basically just the weight of the melon. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then the frequency, like the frequency of 1 is 2, right? And the frequency of 2 is 5. The frequency of 3 is 10. And then the next one is 13. The 5 is 7. And then the last one is the 6 is what was it? It's 3. Yeah. Okay, here we go. Now, what we're because we're looking for the median or the quartile, so what we need to see is only this cumulative frequency. So let's write it down. Okay, cumulative frequency start from 2 because the frequency starts with 2, and then the next one is just adding this number with the next number, which is 5. Now, a lot of ways on how to see this, how to interpret this this number here. So let me just finish writing down all the values for the cumulative frequency. Okay? So 7 plus 10 is 17, 17 plus 13 is 30, 30 plus 7 is 37, 37 plus 3 is 40. So there are 40 data here. Now, a lot of way on how to read this data here. For example, 2 here, meaning that the first and the second data is this guy. This meaning that the third until the seventh data, because the data number 1 and 2 is 1, so 2 begins from the third data, right? So the third data and the seventh data is 2, right? And then which means that the eighth data after 7 is 8, right? The eighth data until the 17th data is 3, and so on. Okay, so how is this going to help you? Because when we're searching for the median and the quartiles, you only basically just splitting those into like a couple parts. So if I have, for example, like data number 1 until data 40, when you want to know the median, you only need to split this into 2 equal parts, right? So when you split this into equal parts, you will get 20 data on the left side and 20 data on the right side. So the median is between the 20th and the 21st data. And then you need to locate them. Where is it here? Now, when the 20 and the 20th data, so because in here we have an even number of data, so you will get like these two data and then divided by 2. Yeah, add them together and then divide by 2. So if the data are in the same location, you only need to take that number, the value of x of for that class. Okay, so the 20th data is, we know that it's in here because we know that this here is data number 18 until the 30th data, because this is data number 17, meaning that the next data is data number 18, right? So data number 18 until number 30 is here, right? Which is 4. And then the 21st and the 21st, the 20th and the 21st data, basically both of them are in that class, so the median is just 4. Okay, so that is the median. This equals to 4. Okay, now how about the quartiles? So the same thing, when you split this into 2 equal parts, then you need also to split them also into 2 equal parts. On the left side equals 2 equal parts, on the right side also equal part. Now we know that we have 20 data over here, right? So the middle one should be between the 10th and the 11th data. So how do I get this 10 and 11? It's actually basically just adding 1 by 21 by 20, which is 21. 21 divided by 2 is 10.5. 10.5 is in the middle of 10 and 11, right? So there we go. So let's find data number 10 and number 11 again from this table of CF. So it's both of them are here, right? Again, this is data number 8, again after 7 is 8 until 17. So data number 10 and 11 is both of them are here, so the quartile 1 will be over here. This is quartile 3. So the quartile 1 will be equals to 3. Okay, the same thing here. So when you want to know where is it, just add these two numbers, right? 21 plus 40 is 61. 61 divided by 2 is 30.5. 30.5 is between 30 and 31. So you find the 30 and the 30th data, and you will get that. So actually here we have 30 data over here, and then which is the 30th data, and the 31st data is over here. So basically, you need to add these two numbers, right? And then divide it by 2. Because the 30th data is 4 and the 31st data is 5. So the part for the third quartile or the upper quartile, quartile 3, you need to add these two numbers, 4 plus 5, and then divide by 2, and you'll get 4. And you get this answer over here. Okay? So that's it for the discussion, not discussion actually, the explanation for all of them. So basically, just read again. Okay, so and then redo the question if you want. I will send you the PDF for this question, and maybe you want to redo it again. And then for the next session, I hope if I still have time, I will make the video. If I don't, then yeah, just use the what do you call it, all the papers that I gave you before, and then just read all from those, and the question will be most likely pretty much likely from those questions. Okay, so good luck for the examination next week, and see you again.